Hey everyone, here's our 9.3 notes for today. We have a couple theorems and a vocab word. We have the vocab word geometric mean. We will use this later on, so we won't fill that in right now. Let's go on to our theorems for today. So if we look at the theorems, we have this right triangle similarity theorem. This states if we have a big right triangle here and we extend from the right angle to the hypotenuse, this altitude, it will create two smaller triangles. And it just so happens all three of these triangles are going to be similar to each other. A little reminder, similar triangles mean that the corresponding side lengths are proportional, which will get us into some stuff we'll have later. Let's look at geometric mean. So the geometric mean of two positive numbers, a and b, is the positive number x that satisfies the following equation. Now, you'll notice that if we wanted to solve for x in this very specific equation, I would have to cross multiply. So x times x gives me x squared, b times a gives me this ab, and to solve for x squared, I take the square root. So the geometric mean between two numbers is just taking the square root of their product. And we'll see some examples of that later as well. Now we have some theorems that deal with the geometric mean. And this also goes back to the triangles being similar, which means the side lengths are proportional for the theorem to work. So real quick, if I look at the two triangles being maybe the smaller ones being drawn separately. So let's do our CDB triangle here and our ACD triangle here. Go back to the parts that correspond. I can look at CD in my smaller triangle corresponds with AD. So I'm going to write that. I'm going to say CD goes with AD. This ratio should be proportional. Now let's look at the other leg of each triangle. So now let's look at DB. So that's going to go on the top of second fraction. And that's going to correspond with CD, not B. I can't read my own handwriting. That's going to go with CD. Now, if I wanted to then apply my geometric mean, if I cross multiply here, so cross multiply, I'm going to get CD squared equals AD times BD. Now, they both have that CD in common. Just so happens that CD is your altitude. So what does this mean? This means, if you want to put it down to regular language, that here's the key here, your altitude squared is equal to the two parts of your hypotenuse multiplied together. What I mean about parts, let's look. If I look at AD and BD, if I look at my altitude in this specific question here, so here is my altitude. My altitude cuts my hypotenuse into two parts. I have a part between A and D and another part between D and B. And so if I multiply those together, which is right here, that equals my altitude being squared. So this is the main equation here. Instead of memorizing it with CD squared equals AD times BD, you would want to think of it as the altitude squared is equal to the two parts of that hypotenuse multiplied together. Now, without going through this whole setting up the corresponding parts, then we have the geometric mean leg theorem, which ignores, in a way, the altitude. And let's look at what it has here. It says that CB squared. So let's look at this whole larger triangle. We have our hypotenuse down here at the bottom. We have a leg, and we have another leg. So what this is saying, if I highlight here, CB squared. So this is saying if I have a leg, I'm going to write this down. If I have a leg and I square it, it's equal to, now this says DB. DB right here is a part of the hypotenuse that actually is adjacent to the leg. So I'll put part here, times. And then AB, if you look, AB is the entire hypotenuse, the whole part of the hypotenuse. So this would be the other equation. Your leg squared equals part times whole. So let's apply this on the next page. All right, let's go through some of these. Identifying similar triangles. I'm just going to do one of these really quick. So I'm going to just write these also in like a similarity statement. So I'm going to start off with my larger triangle. I like to put my right angle first. So I'm going to say triangle HJI. So I'm going to put my right angle in the middle. So here's my right angle. I'm going to identify this with a little highlighting of red. Okay, these are all going to be similar to, so this is similar to this other triangle, and I want to write down all of my triangles. So my right angles need to be in the middle here because when you have similarity statements, the corresponding parts of those statements need to be congruent in terms of your angle measurements. So I'm going to fill in some stuff here. If I look at the triangle on the left, my right angle is the K. Now notice my H will stay the same measurement, and because of the reflexive property, H is going to also line up with H, and what is left is J. Now let's go to the smaller triangle on the right. My right angle is K. My I, because of the reflexive property, is going to stay the same measure as I. What's going to be left is my J. So here are my three triangles that are similar to each other, written them in like a similarity statement so that all the parts line up that correspond correctly with each other. I'm going to skip number 2. Let's go ahead and find the geometric mean. So geometric mean, remember, is you're going to multiply the two together and find the square root. So I'm going to say the mean is just the square root of 2 times 6. I'm going to break down my factor tree. So 2 stays 2, 6 is 2 times 3. I have a pair of 2s, so I pull those out, keep the square root of 3. There's my answer. I want to do simplified radical form. For 45 and 5, I would say the square root of 5 times 45, which 5 is 5. 45 is 5 times 9. So I have a pair of 5s. And then 9 is 3 times 3. So there's no random ones left over. So this is going to equal 3 times 5, which is 15. So there's your geometric mean with two numbers. Now let's look at number 5 here. Number 5, I am looking for what's called the altitude, and I'm given the parts of my hypotenuse. So I'm going to really quickly rewrite my equation that was that my altitude squared equals my part times the part. So my altitude here is x, so x squared equals, the parts are going to be 9 and 16, so 9 times 16. So I'm going to take that square root of both sides. And I'm going to get the x equals, well, let's break this down. 9 is 3 times 3. 16 is 4 times 4. So you have two pairs. So 3 times 4 means this is going to be 12. Now, I'm going to skip number 6 really quick, and we're going to go to number 8 because we're going to use the same theorem here because I have my altitude and I have my two parts. So again, altitude squared equals part times part. So my altitude here is 6, so 6 squared equals one part is 3, the other part is a plus 4. Now these directions do say to find the value of the variable, so I do not have to plug it back in, I just need to solve this. So I'm going to get 36 equals 3a plus 12. Subtract my 12, I get 24 equals 3a. When I divide, I get a equals 8. Let's go look at number 6 now. The reason why I took a little break is I want to look at number 6 because now I don't care about the altitude. I am focusing on a leg. So our equation said that our leg squared equals part times the whole. Our leg is y. The part has to be the part of the hypotenuse that is adjacent to the leg that we're looking at, which is the 9. And the whole means 9 plus 2, so all this added together is 11, so 9 times 11. And now I can take my square root to solve for y. I'm going to get that y equals, well, 9 is 3 times 3. 11 is prime, so it stays 11. I have a pair of 3s, so I get 3 square root 11. And now let's look at number 7. This is a great one because it's an interesting picture just to look at. My 49 here is a leg, and then I have my part and I have my whole. I don't have the altitude. So here I'm going to say that my leg squared equals my part times the whole. So 49 squared equals the part of the hypotenuse that touches 49, which is 7, times the whole, which is t. So now I'm going to take 49 squared and divide it by 7, and I get 343 equals t. All right, there are your notes. If you have any questions, reach out. If not, we'll see you in class or the next video.